First thing I want to ask you is, do you want to have speaker, or do you want to have speaker, talk? Or how you're all grown-ups, how do you feel it would be best at this time on a Tuesday morning to get your head around fires and boilers? Any preferences?
One at a time.
One at a time. Okay, is everybody happy with one at a time?
Yeah.
Okay, right.
More than both at once.
More than both at once. The two really related. Excellent. Well, what we'll do then is I'll have a presentation from Andrew and a discussion about that, and then in about half an hour or so we'll move on to hear from Claire about arson and so on, and then we'll have a good chat about that as well. Okay? This really is an opportunity for a number of things to be explored. So the talks will give us some detail about two specific cases, but that may well inspire you to other thoughts or experiences of your own. So I'm going to hand over to Andrew now, who is going to reveal all about a Perkins heating system. Which does, I can't get to the idea of a Perkins without having a sort of hat on it, like something from a railway cartoon. But we shall hear more, and there are some juicy pictures. And again, it will be recorded, and the PowerPoint, I think, will be available in due course. Thank you.
Thank you and good morning. That's what we're talking about. Reusing a historic Perkins heating system, and all will be explained shortly. That's who I am. From Historic England, Building Services Engineer. So, what I'm going to do now is do something slightly unusual, and this is a bit of a quiz to provoke some discussion and introduce two concepts that you probably haven't thought about relating to heating systems. This will particularly appeal to petrol heads. We're looking at petrol heads here. So, what we're going to do is consider three current vehicles. So, the first one is a Toyota Prius. This is a rather sad looking Toyota Prius. You'll notice it's already starting to get rust around the wheel arch where it's got slightly straight, and that's just outside my house in South London. This Land Rover Defender. This is my own car, affectionately known as the Sugar Cube for fairly obvious reasons. And the last one we look at is a rather garish Jeep Wrangler. Okay, so you'll have seen all of these trundling around the streets of the UK in greater or lesser numbers. The Toyota Prius, you'll see them in a lot of town centres. They use a sort of de facto mini cab. The Land Rover you all know about. The Jeep Wrangler's not quite so common, but you'll recognise it as a derivative of the wartime Jeep. So the Toyota Prius, petrol-electric hybrid, steel body, very large battery pack and lots of complicated electronics. The Land Rover Defender, diesel chassis, diesel engine, massive steel chassis. In fact, it's really just a steel chassis with wheels. The mostly aluminium body is just to cover the wheels and for something for you to sit in. It's not structural, and some electronics. The Jeep Wrangler, diesel engine, steel chassis and body which work together. So the steel body is structural and relies on the chassis and vice versa, and more electronics than the Land Rover. Now you're probably all thinking, what on earth has this got to do with historic building services? Roll with me, it will make sense. So, question. And the question is this. From extracting the raw materials, all stages of manufacture, through using the vehicle, to eventually dismantling and recycling, which of the three vehicles is the most environmentally friendly?
Oh, Land Rover. Yes, probably the Jeep.
And
Not
what
the Prius.
Not the price.
No. Okay, why not the
Otherwise you would ask the question.
Yes, the Toyota Prius is a bit of a disaster because they actually have quite a short life. You saw the one there was getting slightly scruffy already. The battery packs don't last the length of the vehicle, very expensive to replace, and I suspect a lot of them will never have the battery packs replaced and will just run on the little petrol engine. Now, the Land Rover and the Jeep is an interesting discussion because the Jeep is a steel body, steel cast iron engine, and the steel is easy to build easy to make and easy to recycle. The Land Rover, being lots of aluminium body, the aluminium is very expensive to make. But the Land Rover will probably last an indefinite life. Yes, 2/3 of the Land Rovers ever built are still on the road, or still at least driving around, if not entirely road legal. Half of Rolls Royces are still going, and nobody bothers to count the rest. So it's a debate really between the Land Rover and its infinite possibilities of being able to be rebuilt versus the steel Jeep. And probably the Land Rover, even allowing for the aluminium in its body, is probably eases ahead on the sort of long-term life and environmental impact. My Land Rover it's hot riveted together at the bottom, so when it falls apart, I can rebuild the body quite easily. I mean, they are ludicrously simple to modify because of that huge steel chassis. And, oh well, as it sounds discussed, we've discussed. And we'll revisit the concepts of embedded energy and the adaptation and restoration, in our case, historic equipment a bit later on. So that kind of sets the scene on embedded energy. It's used this enormous amount of energy to make the cars, far more than they'll ever use.
Is it really that much?
Oh yes, it's an enormous amount of energy to make, especially aluminium, a huge electrolytic or electric process, and a vast amount of energy for making the steel.
Purely carbon tire.
Yes, yes. The usage of the petrol or diesel pales into insignificance. It's quite interesting. Okay, now, to avoid death by PowerPoint, I have a handout. So, take one, pass them round, back to me there. Every which way round for ease of packing. And so what I'll do is I'll refer to the sections in the handout as we go along. So a little bit about Historic England and its planning group, part of that function. And Building Services Engineering team, we advise by request from them various types of inspectors, architects, surveyors who look after 9 regional offices. And I put the details of the regional offices and my team I work with in the handout, so you can explore that. Formal advice goes through the planning system, so in various inspectors, but we're happy to give informal advice and also just hear about interesting bits of building services that you find along the way. Okay, let's get down to the church. This is the Parish Church of St Michael and All Angels, or Cornwood Church for short. It's in Devon. It's a Grade 1 Anglican parish church. It's in the Dartmoor National Park, about 10 miles to the east of Plymouth, and a few miles north of Ivory Bridge, which is the nearest railway station. And I've put the listing information for the church in the handout. I've slightly edited it to make it slightly more readable, but I've not changed the actual technical contents, and you get a feel for the significance of the church. The church had a heating system. It wasn't terribly effective, and the parish wanted to do something to improve matters. So I went down with my colleague Geraldine O'Farrell, myself, Frank Ferris from the Sibsey Heritage Group, and a bit more about the Sibsey Heritage Group a bit later on, Francis Kelly, the local inspector, and we met with the church wardens, the church architect, and the DAC heating advisor back in July 2012 to see what could be done. Now, here's a question for you. The first heating system lay under a grill, which is a sort of void. The grill's gone, the void has been filled in, it's where the matting is, which is now being recarpeted. Rumour has it, well, we found a number of these in churches, and we really don't understand how they work. Rumour has it that they used some form of solid fuel burning in a grate or a basket which was lowered into the void. But how exactly they operated, we really don't know. We've heard rumours that they were just stoked up and left ticking over for months at a time and then emptied once a year. But we really don't know much about these. And so if anyone finds out how these operate...
I think I've got one. I think I've got one in my show.
Okay, well...
Where would the smoke go?
I'll tell you exactly how it goes. It goes on a horizontal flue, and then it goes into that straight up chimney.
Yes, and some just seem to just percolate up through. Some were on horizontal flues, some just set there like an...
So sort of like a baxi works the way round.
Yeah. But
Some of them are linked into the pew platform space, and so sort of air came in through the air bricks,
right,
and the smoke sort of dissipated.
Just a bit like an hypercaust system.
Yeah.
Yes,
Yeah.
and we have found more elaborate hypercaust systems as well. They're being researched by Frank from the System Heritage Group.
I'll go down to some photos.
Brilliant, thank you. So that was the original heating system as far as we can determine. The second system was this. This is the Perkins system. This is the elaborate pipe coils. This is one of the bigger ones. There's about 3 or 4 of these in the church. And put in 1840s, 1850s, something like that. Still used. Slightly modified. You can just see where they'd actually welded a piece of ordinary steel piping, and then this went around a toilet area and then rejoined back again. So that was one type of the heat emitters.
Can I ask, sorry, what's going through the pipes?
Water.
Water, so it's a hot water system?
Yes. Originally it was high temperature, high pressure. I'll come on to that in a second. So yes, it's a water system. One of our young engineers in the office thought that if the Italians designed something like that, it would look quite snazzy, but then powder coated in some bright colour, pink and yellow. And it really works in a very similar fashion to a towel rail. So it's a really quite early radiator. The Victorians were very good at working out what to do with tube, and then later we got into sort of cast iron radiators and things. So that was relatively straightforward technology. The other heating system are these amazing pipe loops, which is zigzag backwards and forwards, and these would have either been formed on site, or they would have made them to length and then bought them and then assembled them on site. So this is like the pipe coils that you used to see under the benches in school changing rooms. You sometimes still see them in places like police stations and army barracks, and the drying rooms where they dry the clothes.
So that's the same. That's the same date.
Yes, yes, same system.
Must be later.
Sorry?
Must be later.
No, it was all part of the same system. So it was just the 2 versions of the same. So low level were these.
But just looking at the pews. The pews aren't 1830s.
1850.
More 1850s.
Yeah, you said 1840.
And it looks like they're made. It's all made in the floor and everything. It's all sort of
Don't know, it's
high rather than low.
very difficult to date. That's part of the problem.
Right.
The Perkins systems were installed from the 1830s to the 1890s. And they were some of the earliest sort of heating types used in buildings. The surviving systems by the Perkins family, there were a number of generations. Very rare, and we need to preserve them.
Is this Perkins of Peterborough?
No, it's not the same as the diesel factory. As far as we know, we don't believe there is any connection. Perkins was born in this country, studied in America, learned quite a lot about heating in America, and came back. It's unusual to find them surviving, and even more unusual to find them actually working. So anything we do to them needs to be carefully considered because of their historical importance. And there's much more about the Perkins and Perkins systems on the City Heritage website, and I've given you the link there. And our colleagues from the City Heritage Group have done an awful lot of research on the Perkins, and rather than kill you by PowerPoint, go away, have a read of the website. And it's a fascinating resource. In fact, the British Library have captured one version of it to preserve posterity because they think the website is so interesting, which is quite amazing. Okay, the original system was designed to be operated at high temperature and high pressure and was pressurised by a sealed vessel, fed by a solid fuel stove, which is now long gone. And you can see the relative dimensions. So that's what a normal steel pipe, inch and a quarter heavy gauge steel pipe would look like. And the Perkins pipe looks very similar visually, which has fooled a lot of people. But look at the thickness of the wall. Really heavy duty hydraulic pipe work. They ran at quite a high temperature, and it was not unknown for the Perkins systems to accidentally set fire to buildings. I mean, they are running, 200 or 300 degrees, seriously hot.
This is wise.
Sorry? No. So it wasn't one of the world's brightest ideas. So a lot of them are now being downrated to the usual low temperature hot water, low pressure hot water standards, and in this case fed by a conventional oil-fired boiler, pressurisation unit and a pump. The boiler was sized rightly for the heat load. The pump had about the right flow, but not the right pressure head. So there wasn't enough pressure to get the water through this tiny little pipe. And so it's and that's really where we came in. That's the same coil we looked at earlier, repainted. Now, they did a very good job of cleaning the rather scruffy pipework up. But the colour is interesting. The lower colour actually matches quite well the pews, and there are also some quarry tiles around the edge of the church, and that colour is not bad. What we found was the silver paint doesn't help matters at all, and would have cut the output by about 50%. It's all to do with the emissivity of the outer surface finish of pipework. So the silvery paint, the metallic particles, effectively is pushing the heat back into the pipe. But a company called Ideal, working in the 1920s, found that if you overpaint the pipework with ordinary gloss oil paint or gloss varnish, restores the output, and there's a table about that in the handout. So that was an easy fix for them to do.
Do you want high emissivity or low emissivity for your paint?
Pass. I'm not a physicist, I'm just a simple engineer. The idea is a smooth oil paint or smooth varnish. And I think it's to do with the smoothness of that final finish.
So it's not necessarily the colour?
No. When you look at the table, you'll see that there's very little difference between matte black and post office red. You always think that, if you paint something matte black, it will give out more heat. Matte black will absorb more heat. That's why Ford Transits are painted white. Not only is the white very cheap titanium dioxide, the story goes that a black Ford Transit van was sitting outside the factory, Dagenham, I guess, and a Ford executive put his hand on it and got his hand burnt. So he said all the vans now will be white, which actually made for cheaper paintwork. But so absorbing heat, yes, the colour does is crucial, but for giving heat out, it doesn't matter so much. So a matte finish, a satin finish, or a gloss doesn't really matter. It's the metallic particles that really will screw the output. That's fairly straightforward, so they got on and did that. We think that the colour could be better, so the suggestion is where you've got against the off-white wall, an off-white system. There's some pipework against the stonework, so a sort of grey stone colour, and then where it's against the brown pews or against the red quarries, this brown actually matches quite well. And we've given some guidance on paint systems to be used in the handout. There's three common standards: BS 4800, which was post-war, BS 381C, which was codified some pre-war industrial and military non-switch colours, which is quite handy, although the colours are quite deep. And then there's the RAL system, but that started in the 1920s, mostly on Central European type colours. So some of those look a bit garish to modern eyes. So that's one way of doing it. The other way is to look at some of the heritage paint colours. Dulux do blue and green. There's a number of companies that do it nationally. But we've also found some local suppliers of paint who will only sell perhaps in their immediate localities. We found a supplier in London, found one in Devon. And so there are a number of small paint companies that will make heritage type colours quite specific to an area.
So just to go, if somebody came, sorry, I'm Janet Ferrer, I'm head of conservation at Church Care, so
Yep.
it's important to get this right. If somebody were, if a church were to go to, say, Dulux and buy their, you can buy radiator paint.
Yes.
Is that the kind of thing that you would suggest is
No.
good? No.
Well, the problem with radiator paints will do admirably, but it's whether you can get that shade again, because a lot of the decorative paints are very fashionable. So this year's lime green, you may only get it for this year, and trying to get that paint again is very difficult. So we're suggesting, as far as is practically possible, use paints that are always going to be available again. So for the British standards, you can even buy those, you can buy them online, you can even go into Halfords and get them as an aerosol can if you're doing small details. So you're always going to get those colours again from the three standards. The heritage colours will probably be around a long while.
So that's from an availability point of view, not from an immersivity point
No,
of view?
it purely for ease of repeating the redecoration.
Okay.
So rather than everyone saying, what colour did we paint this? And nobody remembers and have to do the research. They can say, right, it's a standard colour, we can do it again. But any quality oil-based paint will do. So the normal oil-based gloss is fine. Okay, another query for you. You'll spot the obvious mistake of why would you put the yellow paintbrush on a blue blood? And a particularly gormless painter, but that's clip art for you. A query has arisen as to what colour these heating systems were originally painted. Frank from City Heritage Groups thinks they were just left in bare metal and probably just polished with a sort of black lead, actually a graphite system that you used for coal-fired ranges and the like. I think they were actually painted black. And the Victorian technical gloss paint has now gone sort of semi-matte or matte. And basically we don't know. We haven't got any records to say what the systems were. And it may have been a regional thing. Frank does a lot of work down in the West Country, and a lot of the buildings I've been looking at have been in London and sort of over to the east. So it may be a regional thing. So if any of you are working in churches looking at parish records and you come across the sort of parish records is we paid Sid and Eric 7 and 6 to paint the radiators, and it gives a detail and some dates, do let us know, because it will start to build up. I mean, we could do the analysis by stripping the paint off the radiators, but that will only tell you the first colour. What it won't tell us is when that first colour was applied, necessarily. So that's a query for folks to mull over. Okay, back to Cornwall Church. Another easy adjustment we made was to the controls and the temperatures we ran things at. So what we suggested was run the heating system constantly at a lower temperature, about 12 degrees C was what the parish hit on, largely because that was the lowest setting that we get on the thermostat, and then boost it for the services. Now it sounds counterintuitive, really does, but it works. The parish had even with the Duff thermostat, the parish meticulously recorded each week their oil consumption, and running in this mode of low background heat and boosting it they didn't think there was any difference in the oil consumption. And once they'd fixed the thermostat, they thought it was going to be again much the same or very slightly more. But even a modest extra expenditure versus the difference it made to the way the church felt was considerable and well worth it. And we've come across it being used for a different reason elsewhere. And one of the installers, a company called Christopher Dunphy Heating, some of you may have come across, he also sets the heating system that he installs up in the same way.
Oh, were they running it previously?
They were running it in the classic way of turning it on a Saturday so it's warm for Sunday, then turning it off again.
Church warden used to have to go at 4 in the morning to turn the heating on.
Yes. So effectively you're heating from stone cold. Now, it's not as bad as it could be in Dartmoor, because that the area is fairly well buffered, so it's a fairly mild climate. It rarely gets below 0. But you're still heating from cold right the way up and then letting it cool down. So running it at low background temperature really does work. It sounds extraordinary, but it works. And this is one of the great strengths of the modern digital controls, especially the sort of wireless systems. I can now drive my central heating at home from my smartphone or from my iPad. And they make setting the systems up and fine-tuning them really easily, because rather than relying on a little twiddly switch, which is difficult to know what it's doing, you're actually doing a digital reading, so you can experiment.
Can I ask, whilst the parish were doing this experiment in terms of the low background heating and the difference in terms of how it felt, is there any historic interior that they were also monitoring for any changes in how that was reacting to the changes in temperature? Because it could be beneficial as well as...
Yes. No, there was nothing specifically sensitive. No. No, it was fairly straightforward. And to be honest, other than organs, which are very temperature and humidity sensitive, a lot of the standard fittings in the parish church are fairly robust. So if you think about an oak pew, once it's seasoned, it will get warm in summer anyway, especially if sunlight is hitting it. Adjusting the heating system isn't going to have any great adverse effect. A lot of the fittings inside the church are fairly robust.
Surfaces.
Sorry?
I would possibly disagree. It depends on the fitting.
It depends on the fittings,
And it
but a
depends on
lot
the
of the
heating
standard materials used are fairly robust. It's where you've got delicate artworks, but then you would consider things separately. But running it at a constant temperature is going to help anyway, because it's the sudden changes are going to affect the expansion.
And the changes in the humidity.
It's I mean, it's when you've got sort of areas of wall painting or the remains of a timber ceiling, where you want to avoid condensation on those surfaces.
And then running
in our area we've got a lot of clunch, which is a very absorbent stone, and it's often quite fragile. The Lady Chapel at Ely has been monitored for some years since they put in underfloor heating, because there's polychrome on the clunch.
Yes,
and that's shown to be beneficial.
Yes, it will. Anything that you can do to stabilise the conditions will help greatly. Cool winter there wasn't.
It's very wet in Cornwall.
Yeah,
It's very damp,
Very damp.
acidic.
But it was the interior was.
But even if it's damp and you've got
your objects and your pews that are used to damp.
They're constant.
You introduce heat, you introduce change.
Yeah,
so
but
there is the potential.
yes,
I'm
but
not saying
you're
that there is
more
damage, but
yes, but what you're doing, rather than the sort of yo-yo effect of nothing, hot, back to nothing over a couple of days, by keeping it at background temperature and only boosting, the thermal impact is much less.
No, I'm not saying anything that's wrong. I'm just saying that it's the kind of thing that would be useful to be monitored whilst it's happening, so that we have the data and the evidence that it's not actually causing any damage. That's the
Particularly the long-term effects on humidity, because if for the whole of the winter that results in it being 45% or something, that's going to be a lot more drier than it's used to being. And regardless of the change in temperature, that can really affect any sort of organic materials, as you like to say.
Yes, yes.
The good news is that low-cost USB temperature and relative humidity sensors are easily available. You can put in locations and then down. I think that's one. Yeah, let's experiment and see. But the initial feelings are that it's just making the system, using the system that way, making the churches feel better. So, this is where it all got slightly complicated. We suggested a means of inserting some extra flat steel panel wall-mounted radiators to sort of give a neutral appearance against the mostly plain walls and insert them into the Perkins system. And that would have retained also the Perkins pipework and all the pipe coils and those low-level pipe loops. But would have required some special pipe adapters, but only a modest number. And the parish had the system designed, but the cost of the 5 radiators was staggering £15,000. So the alternative would have been a lot. This is because they were specials. As soon as you get away from the standard range, the cost goes through the roof. So the alternative would have been lots of the standard size radiators, quite a lot. So that isn't going to be terribly practical or cost effective. We weren't aware of that till the parish had done some lateral thinking, and they salvaged from a Victorian church that's being demolished in Plymouth somewhere. It's building apparently of little architectural merit or no future utility. I don't know much about the building, but they managed to get hold of 5 out of the 6 cast iron radiators available. Well, oddly, these were made by Beeston, way up in Nottingham. Beeston went out of business a couple of years ago, but they were installed by Hayden. Hayden are a local supplier or local installer working in the West Country. And you can actually see this is Princess, is one of Beeston brand names. But Hayden obviously had these air vent fittings made up with their name on. And apparently that was not uncommon practice. The radiators probably dated sometime between 1900 and World War II. A bit difficult to date them any more closely than that. And a local member of the community apparently paid for the transport on the back of a flatbed truck with a higher crane. And more members of the community manhandled the radiators into the church in approximately the right position. So that left them with a dilemma of what exactly to do, so we gathered with them again to give them some more revised advice, and we thought the easiest way of installing or using these was to run a separate set of pipe around the church just to feed the new radiators. Because they were floor mounted rather than wall mounted. It just seemed the easiest way of doing it, and that would have left, it sort of mimicked the Perkins pipe work and left most of the Perkins pipe work system undisturbed. Now there was something that was happening in the background that we weren't aware of, is that they'd got the faculty for the first system. We'd made the suggestions and they didn't get the faculty for the revised system, which was slightly frustrating. In fact, we weren't aware that they'd got the faculty for the first system. And what we think is, if we were doing this again, Francis, Kelly and I were talking about this, I think what we would do is we'd recommend to the church that church should take advice, get something designed and costed, so you know it's affordable or not affordable, or buildable or not buildable, then apply for the faculty. Because then it goes through much more smoothly, because it's very frustrating to get the faculty and then realise it's not affordable, and then go back and get the faculty revised, because that's just...
I think this is right, because I'm chair of the DAC, and of course this is actually very close to our hearts.
Yes.
It's a great one. This is church. You've seen the reasons for listing, which interestingly doesn't include Perkins.
No.
So in terms of a hierarchy of importance, the system is lower down than the interior. And now I know we've got some pictures showing the pipework around the doors and things like that. They will have to apply for a faculty. They will have to come to the DAC in accordance with the rules that we heard about yesterday, and to Historic England, Francis Kelly's colleagues. And I don't know, but it's quite possible that they will get a faculty. It's quite possible, therefore, they'll have to take what they're putting out, which will cost well.
Taking it out is relatively inexpensive,
but
it's back in again,
but
very frustrating.
In terms of the saving that they thought they were making,
yes,
they may not make at all.
No. So
and I think one of the key issues of this conference, actually, from my perspective, not being a specialist in heritage and that sort of thing, is that there has to be absolute joined-up thinking between the church, between all the advisory bodies, and between the various functions in various advisory bodies. We've had some superb, and this is, I'm really interested in this, but we had some superb papers yesterday, 20th Century Society, Victorian Society, Pre-Victorian Society. Everybody's got to work together. Everybody's got to communicate together. Because if they don't, the church will take their advice and then go off and put it in without...
Yes, and frustratingly, they didn't quite put it in as we suggested for the Mark to anyone, which is even more frustrating, especially as we get the contractors round to explain what we were trying to do. Yes. So again, this is one where
wrong contractor.
Yes, and it is another perceived slight weakness is the supervision of the contractor. So it is one of the disadvantages of the functions being spread out across the country. So the diocese is based in Exeter, which is a distance away. Francis is based in Bristol, I'm in London, and the contractor will be somewhere down in probably Plymouth. So there's a little bit of sort of logistics of making sure everybody is all connected, fully understands
what we try to do, and may almost make a discipline of it, is right at the start, is to have a process discussion with the church, the PCC, with all the consultees there.
Which did happen in this case.
Which happened originally, and not subsequently.
But the whole the church's system is based on the presumption that the parish church, the parish, can run the whole thing. And if you've got the proverbial, six little old ladies, I mean, who is actually going to pull all this together? Whereas the secular system, the local authority, you apply to local authority, they do the consultation, they make sure, and it's not until it's all to their satisfaction that the thing is given. Now, there are one or two dioceses that do that, and in Eden Diocese, I'm chair of Ely, the very the better resourced dioceses, shall we say. In Eden Diocese,
through the system though, the online system.
Yes, that's true.
But worse,
at the moment, we only do the really difficult, really heavy ones.
Ladies is a very powerful church warden.
Yes. Oh yes.
And want to push something through.
Yes. And that's a disadvantage as well, which is.
No, that's fine because it fills. Yes, it fills in the background. So this is another radiator that we've repainted. This is the classic example of that we spotted where they hadn't done what we had hoped they would do. So this is the Perkins pipework at the bottom. You see it's a formed bend. And what we envisaged was that this would be another formed bend in steel, plain welded. So it would have mirrored that. And then this would have been, we envisaged that being left in the brown, and this would have been in the light colour to match the wall. So that was the plan, and they didn't put it in. So what we're going to do is work with the parish just after Christmas and help them write up the revised or their application for a retrospective faculty and address these issues. There's some, they need to adjust some pipe work where it goes around a doorway, it needs to be raised and so it can be boxed in, and some general boxing in, and some air vents at a high level. So
just before that kind of happens, I think it'd be worth discussing that with Francis Kelly, because I think he's going to be supportive of actually removing all of the new pipework and slotting the new radiators into the...
So Francis and I are going to batch this through together after Christmas. The other thing we're going to get the parish to do is to do the thinking about what colour this should be, because we can't do the colour matching from photography from a distance. So
can I just ask one question? What's the problem with the pipework? It's reversible. You're talking about reversing it.
Yeah, you see the scale of it.
Why not
It's
leave it?
the scale of it. Every single wall has got 4 pipes all the way around, over every door.
over the doors,
So there already,
Yeah,
so it's
they're
2 new
down.
ones.
There's 2 new ones, so they're about this far off the ground around the whole of the church. It's a big invasive.
yes,
aesthetic.
again, they didn't quite match what we were proposing on Mark II. They didn't quite follow the intention, which was very frustrating. Very frustrating. But yes. Notwithstanding the difficulties of the procedures, we can. We can. You can see that with some careful thought of design and the correct approvals, you can actually add to an existing system and preserve and reuse the materials that you've done. So it can be modified to meet the needs of today, and the embedded energy that was expended in the past is not going to waste, and the systems with replacement of boilers and pumps and so on will always be able to be kept going. These are some other ones that we found. This is box-ended radiator in Ladbroke Grove, which is still running, just needs really tidying up. This is one from the English Heritage Estate at Brass Park, still in use, quite unusual style. These were pipe loop ones in Litherland. They were working until the parish accidentally flooded the boiler room to the depth of 5 foot and killed the boilers. In Norfolk. That's it. Thank you.
Thank you very much. Thank you. Now, that started out as being a sort of technical talk about his Victorian heating systems, but as you've heard, it became multi-layered. And so I hope you found that a useful reflection upon not just the technicalities and the conservation